Okay, welcome back. We're talking about the difference between print and print LN. Print LN is going to print the content and then have the cursor drop down, scoot over for the next line. So print just prints. Print LN prints and then preps the new line. Okay, now there's a lot of things you can put in here to I don't know, change the way the output comes out. These are called escape sequences. So the new line, which is really what we're talking about. So by the way, if I was to go back to here, I could make this thing look like a new line. I mean, act just like an LN by just doing this, okay? Because that is what this guy does. It just tacks on a line feed at the end. So now if I run this guy, I'm going to get two separate lines. You know, the hello world line and then the hello from chapter 2. So same thing, right? It's just that it's a very common thing to have something at the end, so they just were nice enough to give you a print LN so you didn't have to deal with it every single time. A tab, you know how when you hit the tab on the keyboard it scoots over, backspace, the return. This one's weird because a return means return the cursor on the same line, scoot on over. But don't drop down, just scoot on over so you could like type on top of it a second time. Now, since all these escape sequences start with a backslash, what if you really wanted a backslash? Well, you'd have to escape the escape, which is this thing. If I want the backslash to appear, I have to put two of them. You know, so what if I wanted a single quote or a double quote? See, this is the part for example, if I wanted to put like the chapter 2 in quotes. Okay, first of all, I got a red line under it, and I got a red eyeball over here saying, what the heck are you talking about? Because I didn't put the escape in there. So I need to put an escape before this one and an escape before that one. Okay, and now when I do this, chapter 2 is going to have quotes around it. Yay, okay, kind of makes sense. Okay, so escape sequences are not complicated. Maybe on a quiz I'll say something to the effect of, here's a print line. You know, how many lines of output is it going to produce? So you just need to look at it and figure it out. Okay, so let me just kind of sort of do one, just to make sure that you're not. So hang on a second. Let me go here, and I'm going to say system.out. I'm going to do just plain old print, and then I'm going to say I don't know. Hello with a tab. My name is. Let's do Bob. And then I am 42. Now, can you look at this and tell me how many lines of output are going to be produced? So is that going to make is that going to make a new line? No, that's a tab. Is that going to make a new line? Well, no, that's just a quote. Is that going to be a new line? Yeah, it is. So this is going to produce two lines of output, right? You should be able to figure that out. Except, I forgot. Wait a minute, that's not. Oh, there it is. Yes, I am, and then junk at the end. Maybe I should have put an LN, one of these guys at the end, just to make it a little cleaner down here. Okay, so hello, tab. My name is Bob. I'm 42. Okay, cool? All right. So, once again, you got to be careful where you're putting these statements. These statements have to be inside a method. If I was to grab this guy, and I weren't paying attention to where I'm putting stuff. By the way, I just use Control X for cut and paste. Okay, the machine's going to say that was a perfectly valid statement, wasn't it? There wasn't anything wrong with it. It worked just fine, except it don't like it here. I got a red eyeball, and the red eyeball basically says, "Hey, illegal start of type cannot find blah 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 blah." What they were basically saying is, dude, this don't belong here. It belongs inside a method. Okay, kind of makes sense. Good. So on page 39, they talk about variables and literals. So variable, if you recall, is just a name spot in memory. So whenever I store something in some sort of a storage bin, I don't want to have to remember the numerical value for the location of that storage bin. I'd rather just call it first name or last name, right? I don't want to have to memorize a bunch of numbers. So that's all that is. So when you declare a variable, you have to give it what's called a data type, because when you're building one of these post office box things, you kind of sort of need to know how big it is, because integers are relatively small. The number 42 can fit in a very small box, but 4,782,000, 0.45 is bigger, and it takes multiple boxes to fit that in. So you need to tell the machine how big of a box you need to put stuff in. Okay. So I'm going to go ahead and do one, and then I promise we're going to come back to it. And that is, I'm going to declare a variable called age. So I'm going to say int, because this is an integer. Ages of humans rarely are fractional. I don't say that I'm 42.8 years old, right? That doesn't work. So if I said int age, okay, so I've declared a variable, an integer variable called age. And then I can assign that thing a value. By the way, I can do all this on one line if I wanted to. I could say int age equals 12. Okay. Hey, why did I get a red exclamation point? Well, because I can't have two things called by the same name. Okay? That makes sense? So, I'm going to show you a cool trick. Right up here, there's a thing on the thing that says comment. So all I have to do is click anywhere inside this guy and say comment, and it'll automatically comment out that line. And then the one next to it is uncomment, which is kind of cool. So if you're writing stuff and you just want to temporarily, like maybe you got it in the wrong order or something, you want to leave it there kind of as a visual reference, just comment it out and move on. Okay, so the equal sign is not an equality operator. We're not testing, we're not asking, hey, is the age equal to 12? No, we're telling it this is an assignment operator, so we're telling it age does equal 12. No questions, we're telling it. Okay, so let's do yet another goofy thing. Let's do another print where we're talking about how to combine. Okay, so we're going to do system.out.println, and then we're going to say, my age is space, and then I'm going to use a plus sign, and then type the word age. Now, the plus sign here does not mean we're doing addition. What it means is I want to there's a cool word for it. It's called concatenate. I don't know who makes all this stuff. Where I take the string, my name is, and then I bolt on the string version of age. Not the numeric version, but the string version of age. So I'm going to run this. And it comes up, my age is 12. Okay, kind of sort of makes sense. Good, let's keep going. So again, the plus sign is what's called the concatenation operator. Horrible term. And it's not doing addition. So what is a literal? A literal is the value, because this is literally 12. Okay, it is a number. 12. Cool. Well, I could do another one for name. Again, let's don't get too bogged down into details, because I'm trying to show you one thing without having to show you other. So don't worry about why I'm doing what I'm doing. So name is equal to, Bob, like that. Okay? So Bob is a string literal. 12 is an integer literal. Okay? This is nothing fancy here. There's nothing weird. It's just they gave names to these things. So a literal, like a string literal, is just something that's in quotation marks. We've been doing that. That's a string literal right there, and there's another one right there, and there's another one here, right? And that's just a thing, same old, same old. So they show some literals, like 20, and today we sold, and bushels of apples. Okay, cool. All right. So what are the rules for creating variables? Ooh, I like rules. Maybe you ought to pay attention. Okay, good. So here are the rules for first of all, there's a bullet list on page 43 that talks about here are their rules. So their rules is the first character's got to be from either upper or lowercase letter or a underscore. They go ahead and say $sign here, but don't do that. That's technically it's allowed, but trust me, don't. Okay. And then after the first character, you can use anything to include numbers. You couldn't start with a number, but you can have numbers in it if it was after the first letter. And then, upper and lowercase are considered completely different. And then identifiers, you can't have a variable with the space in it, which is what kind of reason why we created the camel case, Pascal case thing, is so you can cram things together. And then I add on 2 more. So my rule number 5 is that the name should have some sort of a meaning. In other words, when you're typing in somebody's first name, the variable ought to mean something, like maybe first name. If you're asking for their age, maybe the variable ought to be called age. Don't call it X and Y, because no one knows what X and Y means other than you. So make sure these things describe what they're storing. Okay, that's a good rule. And then the other one is talking about the camel case thing. So yes, when a variable is made up of multiple words, then use the camel case thing where there's a hump in the middle. Okay. So one more time, a camel case is, if I was to go here, let's go here and say, I don't know. Hey, let's go back to this one. This will be a good one. First name, okay? That'd be good, okay? That's a good one because I can tell what that means by just looking at it. And it's camel case because there's 2 words, and then the hump in the middle is what separates the 2 words out. Kind of makes sense? Okay, good. Let's keep going. All right. So, let me get my notes here going. Dang it. Okay. So, just as a convention that everyone tends to use, and that variable names are going to be in camel case, which start with a lowercase letter, and that classes are going to be in Pascal case, start with a capital letter. Okay? Kind of cool? All right. Now, we've kind of sort of talked about this thing called int, which is considered what's called a primitive data type. Ooh, that's a cool term. So on page 44, they talk about the primitive data types. Because when you're storing stuff, sometimes you only need this amount of storage to store something, and sometimes you need this much, and sometimes you need that much. And so the machine just gave names to all these things, but behind the scenes, it doesn't really care about the name. It really cares about how big they are. Okay? Cool. So the Java language is what's considered strongly typed, which means all variables have to be associated with a data type. You can't have a variable without one. Okay. So there's a table on the next page that talks about these guys. And so we have a data type called byte, and one called short, and one called int, and one called long. Now let's look at this. So byte only takes up 1 spot in memory. Short takes up 2 spots. Integer takes up 4, and long takes up 8. Do you see why we're doing this? I'm telling the machine how big this thing is I'm getting ready to store. Okay? Now, float, it's a floating point number with a decimal point numbers. And there's 2 different varieties, a kind of a garden variety one where you don't really care too much about the precision. And then there's a super duper one which has 15 digits of accuracy. That's called a double. And so that's the reason why we're doing this, is because there are different sizes and the machine needs to know the size. Okay, we're coming up on the 15-minute mark, so you guys know how this works.